This is Max Travalen, student number TRE 1600 3622. This is Research Methods Assignment 6. So descriptive statistics. So the key terminology is the standard deviation. This is the difference between the highest and lowest data and the mean average, and it measures dispersion. If there isn't much variation in the results, then the standard deviation will be more close to zero. Range. This is the difference between the highest value and the lowest value in the data collected. This measures dispersion. Mode. This is the most common value in the data, and so the one that occurs the most. This measures central tendency. Median. This is where data is put into order and the middle value is chosen in the set. This measures central tendency. Mean. This is the average of the set of data, which also measures central tendency. Skewness. This shows the peak of a curve, and kurtosis shows how flat or steep a curve is. Inferential statistics. This tests for relationships or differences, and that these relationships or differences weren't caused by chance. 5% is used as a level of chance that could be a factor on the test. This means that there is a 5% chance that the results that you had obtained are wrong. The 5% is converted into the decimal 0.05 and we use the significance level. P is, 0.05 is greater than or equal to the significance. There are two types of inferential tests, which are parametric, which use interval and ratio data, and non-parametric, which use nominal and ordinal data. So there's 4 inferential tests. There's Pearson's product moment correlation coefficient, which tests for a relationship and it is a parametric test. There's Spearman's rank order correlation, which tests for a relationship and is a non-parametric test. There's a t-test, which tests for a difference and is a parametric test. And there's Mann-Whitney-U, which tests for a difference and is a non-parametric test. But we'll go into more details about that. There's 2 types of t-test. These can be dependent or independent. Dependent t-tests test the same group doing the same thing twice. For example, this could be a rugby team doing fitness tests in the pre-season. Independent t-tests test different groups or the same group doing a different thing. For example, 1A tutor group testing their basketball and netball shooting accuracy. Pearson's product moment correlation coefficient. This parametric test tests for relationships. Correlation shows the strength of relationships by using an R value. This identifies whether correlation is significant by testing for 2 variables. Mann-Whitney-U. This is a non-parametric test which tests for differences. It tests how significant 2 independent groups are. This tests the mean of the 2 groups, and therefore, in order to do so, there needs to be 2 samples at the same size. A U value is produced in order to understand the level of significance. Spearman's rank order correlation. This is a non-parametric test that tests for relationships. This is needed with data that is ranked, but not always distributed. This also tests the significance of 2 groups, and it also tests the mean. It needs 2 samples which are the same size. And finally, it creates a U value used to determine the significance. So now for the merit, I'm going to do a research example to show tests. So the research example is there a difference between the netball and basketball shooting abilities in choose group 1A? So here we have the results. This was tested by field-based testing using the netball and basketball hoops in the sports hall. So, first of all, we need to get the descriptive statistics. So we need to go to data, and then go to data analysis, descriptive statistics, and write these 2 tables in the first row, and summary statistics. which gives us is set of data. Now, the mean, the median, and the mode are all higher in the basketball, which show that we were more successful with our basketball shooting. And also the standard deviation is closer to 0, which shows that the range around the mean is less. So there's less variation, meaning that which also shows that we were more successful. It just shows, but it's not a definitive answer if it was more successful, as we haven't conducted the t-test yet. Now, if we go back to first sheet, and now set bar chart. So, if we move this to a new slide, new sheet, do this in name, so and then the axes titles. So then that's done, so go back to sheet 1 again. Now if we do the t-test, so go down to this one. Variable 1 will be the netball column, the first range. Variable 2 being the basketball column. Click labels again. And alfast equals 0.05, as this is the 5% chance represented as a decimal. So okay there. And then the number that we're looking out for is this one here. And as we can see, the number is clearly below 0.05, which states that there is a significant difference between the shooting abilities between netball and basketball in tutor group 1A. So now we've done that, we have to explain why the t-test was chosen. So we know that the parametric has to be interval and ratio, and non-parametric has to be nominal and ordinal data. And so we were using ratio data because we were collecting the frequencies of frequencies of successful basketball and netball shots. So we go down to parametric, and then down to here, so it's interval ratio, and we're analysing the difference because it's a difference between the shooting and netball and basketball. And we need independent because we did netball and basketball, so it's two different sets of data, as netball has its own set of data and basketball has its own set of data. And that's all.